The ideal gas law combines the laws given above to establish the relationship of changing pressure, temperature and volume of an ideal gas when there is no attraction among the molecules. It is a good estimation of the way gases act.
In the gaseous state, the intermolecular or interatomic forces that hold solids and liquids have been overcome by the motion of the particles. The gas particles have too much thermal energy to stay attached to each other. The motion and vibration of the atoms pull the individual molecules apart. This determines how they react physically to changing conditions. A gas will expand to fill the size and shape of its container. Thus, the volume of a gas will be the volume of its container. The atoms and molecules will spread equally throughout the container. Gas particles are in constant motion, colliding with each other and with the walls of their container. When they hit the walls of their container, they cause pressure. Thus, the gas exerts a pressure on all sides of the container that it holds. This pressure increases with the number of hits. The temperature of a gas is a measure of the average kinetic energy of the moving particles. If a gas is heated, the particles move around more quickly as the temperature increases. The gas laws show the relationship between pressure, volume and temperature of an ideal gas. Boyle's law states that the pressure of an ideal gas at constant temperature varies inversely with its volume. Mathematically, it is represented by the equation as shown. The diagram shows that as the external forces increased, the same mass of gas is trapped in an increasingly smaller space. This increases the pressure exerted by the gas on the walls of the container. P multiplied by V is equal to a constant. Charles' law states that the volume of an ideal gas at constant pressure varies directly with its temperature. Mathematically, it is represented by the equation as shown. You can see in the diagram that the gas is at the same pressure, but the temperature has risen from -100 degrees centigrade to 75 degrees centigrade. The gas particles move faster at higher temperatures, collide more often, and now take up a larger space. According to Charles' law, when the temperature of a gas is increased at constant pressure, its volume also increases. V divided by T is equal to a constant. The pressure-temperature law states that the pressure of an ideal gas at constant volume varies directly with the temperature. Mathematically, it is represented by the equation as shown. You can see in the diagram that the gas is at the same volume, but you can see that the temperature has changed from 0 degrees centigrade to 100 degrees centigrade. The gas particles move faster at higher temperatures and collide more often. When the temperature of a gas is increased at constant volume, the pressure exerted by it increases. P divided by T is equal to a constant. The ideal gas law formula is the relationship of changing pressure, temperature and volume of an ideal gas where there is no attraction among the molecules. It is a good estimation of the way gases act. The formula becomes less accurate as the gas becomes more compressed and the temperature decreases. Correction factors are then applied to arrive at the real gas law formula. PV divided by T is a constant.